Hey everybody, so in these next few videos we're going to try to draw some rectangles on the screen using DirectX. And that's not as easy as it sounds. Unlike higher level APIs like GDI or Flash or whatever, there's no simple create rectangle function. And that's because DirectX is kind of a lower level API and it's suited to representing what video cards do well. And the way modern video cards work these days is I tend to think of it kind of like an assembly line. Like an assembly line, you set up a lot of tools and machinery and people, and it's pretty hard to do that. And then the assembly line pumps out output, pumps out cars or trucks or airplanes or whatever. Same way with a video card. A video card, you set up a bunch of things: vertex buffers, textures, shaders, blah blah blah, and then it outputs pixels on the screen on a render target. So, and DirectX matches this. The functions you tend to use are set this on the card, set this on the card, set this on the card, and then go. And then it draws a bunch of pixels, and then you change one or two things, and you say go again. And like the assembly line, while it's relatively awesome at like slamming out results, once everything's set up, it's really slow to retool your graphics, to change the thing your graphics card is set up to do, change the thing the assembly line is set up to build. But the trick to making a good graphics engine is to figure out how to draw everything you need to draw without changing the state of the graphics card too much. And the options we have to work with, the things that a video card, like what we normally twiddle with to make things draw, it's just a set of relatively small number of inputs. It's your vertex stream, one or more, index stream, actually only one, textures, your vertex shader, your pixel shader, your shader state variables, shader constants, and then there's actually a whole bunch of other like one-offy state variables you can set, like render targets and blending modes and so on and so forth. And so by setting all that stuff up, we can then make a draw call, and that's the go, like start processing command to the video card. And that's basically it. So for our rectangles, we're going to want to do the same thing. We're going to write a function, a draw function, that looks basically like set all this stuff and then draw. And we'll go ahead and just say which ones we need. We're not going to, our rectangles are going to be flat, are going to be untextured. It's not actually any state we need to worry about at the moment. We might do some alpha blending in the future, but for the moment we'll just slam rectangles right on top of the screen. And so we need to just call the simple functions, and they're relatively straightforward of what they are. If you go to the device and you say set source stream source, and this sets your vertex streams. We're only going to have one stream, so we can say 0 here. We need a vertex buffer, so we need a vertex buffer there. In theory, you can use vertex buffers to hold multiple sets of data. We're only going to hold one for right now. And then we need to specify the stride, the size, the distance between each vertex. Same thing for the index buffer. Set indices. And this simply takes an index buffer. Go down here and set vertex shader, and it takes a vertex shader. And then set pixel shader, and it takes a pixel shader. Then on our draw call that we're going to use to make this work is draw indexed primitive. Go ahead and look that up for all the fields we need to set. First one is the primitive type, and I won't go into this too much, but the one we want is triangle list, and a triangle list is basically a list of full triangles. So it's 3 vertices representing one triangle, then 3 verts representing the next triangle, then 3 represent the next, and on and on and on. When we get to some of the others, I'll go through what those mean. Then again, some more offsets for schemes that were not for when you want to use one vertex buffer for multiple objects or types of things. We're going to ignore that for a second. Num vertices. Again, start index, so you could use one index buffer for multiple things. And then the primitive count, num primitives. And that's basically it. So our job from here on out is to simply set up all these, DirectX objects and then call these functions. So again, maybe like I should have, like this will show you why I almost always tend to do it in the opposite order, but like we need an init. We need an init function to set up all this stuff. We need a dispose function to clean it all up. And then we have our draw function that's going to do the per frame action. Now I'm going to go ahead and call this system the fill2D system, because I know, say we're drawing Rex, but turns out we'll be able to update this to draw any sort of filled 2D object. The fact that it's a rectangle or not is just, how you set up the vertices, but the scheme that we're using to draw is appropriate for any filled 2D polygon. So I'm going to go ahead and make a struct fill2D globals. I'm going to put in it the variables we're going to need for all these different things. Actually, I forgot one other. One last thing we need is a vertex declaration, and that, because we're sending memory from the CPU to the video card, we need to describe to the video card how we've laid out in memory. How we've laid it out in C is really easy. The program holds that itself when you compile a C++ program. The compiler kind of writes into all the operations, all the assembly of the application, how things are laid out. You're not exactly compiling any code in the C++ compiler that's going to be run on the GPU. We'll get to that in a second. We're going to compile some code, but we're going to call the functions that compile the code in our code. And those are called shaders, shaders being programs that are run on the video card. But to describe the memory layout to the video card, we're going to just call a function with a vertex declaration, a struct that represents how the vertices are laid out. And this is, again, set vertex declaration, and it just takes a vertex declaration. So walking down the list of all the things we need, putting the pointers in our global structure. We need a vertex declaration, and then that's direct3d vertex declaration. Then we need a vertex buffer. Then we need an index buffer. Then we need a vertex shader. And that's vertex shader, and then a pixel shader. All right, and those are the variables we need to fill in. And while we're on a roll here, I'll go ahead and put these in the appropriate places for our inits and updates. So after we've initted all of DirectX, we'll init the specific stuff for D3D. before we dispose all of DirectX, we'll go ahead and dispose all the stuff for the Fill2D system. And here, the Fill2D draw, like that's in the middle of this draw call, or this draw function. We'll draw all the Fill2D stuff. Alrighty there. And let's compile it, just make sure it works. We're going to probably need to organize our code a little bit. So we'll go ahead and put all of this above all of this. And then we'll put Fill2D globals. This is where I said it's not actually this variable is global, but it's going to be a member of the DirectX globals, and so we'll organize it like that, so we know the relationship between DirectX and Fill2D, and that's about it. Go ahead and compile. I'll comment out all these calls for a second, just to make sure we're good to go. And that's it. Okay, so in the next episode, we'll just start cranking through how to create these different variables we're going to need to draw our filled polygons.